We're going on now to topic 5. We're skipping section 4 of chapter 4. So we're going right into linear equations and problem solving. Here we'll be taking words, converting them from English into algebra, and using usually 2 sets of equations to solve these problems. So that's what we're going to be doing. So let's get right up here to where we get started. Now, part of it, as we mentioned in chapter 2, is to read the questions over very carefully. And you can read it to yourself as I read it aloud. One number is 5 less than a second number. Well, here we are allowed to use the 2 letters, X and Y. So we're saying one number is 5 less than a second number. So we can take our X, that'll be one number, is 5 less than a second number. Well, this will be our first, so this is our second. 5 less than that. And twice the second number. Now, here you have to keep in mind that you're designating the X as the first number, and this is the second number. So twice the second number is 2 less than 5 times the first number. So this is the second number. 5 times the first number, which we said was X, and then 2 less. So there are your systems of linear equations in 2 variables converting English into algebra. Now, I've read these already, and I already knew how to set them up. When you read your problem, you're going to have to read and reread. Again, you have the use of 2 variables, and you want to make sense out of them. Now our question is, how do we solve this? Well, if you go into our tool bag, our toolbox, you have X equals this. So this is our value of X. So we're just going to use substitution. So we rewrite it. 2y equals 5. Now our value for X is y minus 5 minus 2. So we remove parentheses, 2y. This is going to be 5y minus 25 minus 2. I'm going to collect like terms, and I get 2y equals 5y minus 27. Now I would like my y's to be positive, so I'm going to transpose this 2y by subtracting 2y from both sides, and I get 3y there. Transpose that, I get 27. I'm going to divide both sides by 3. I get y equals 9. So I now have one of my ordered pair members. Y is 9. Now, since I have it set up here nicely that X equals this, I can take my value of 9, put it right there. 9 minus 5, X will equal 4. So now we look at the question again and say, what do they want us to find? Well, they want us to find the two numbers. So the two numbers are 4 and 9. So not too bad. And we're using things from our toolkit to solve it. Now on your blue sheet, if you get a word problem, this is what I'm looking for. The work neatly and orderly done. So, if you get the wrong answers, I can look and see if I can give any partial credit. Hopefully you'll get the right answers. Now in example 2, as we look at it, talks about two trucks that leave a city and head in the same direction. So a picture might be useful here. So these trucks are heading out and hopefully in the same direction. After 7 hours, the faster truck is 56 miles ahead of the slower truck. So here's the faster truck, and it's 7 hours, and here's the slower truck, and it's gone 7 hours also. The slower truck has traveled 301 miles. So we could do it this way. If they were equal distance, this would be 56 miles more. And we know this is 301. So actually we know the distance that the faster truck went. It went 357. My 5s don't come out very well here. While the slower truck only went this. This is just to indicate the difference between them. So for this, I would suggest we just use the distance formula. Distance equals rate times time. And again, I thought about this already. And we want to find the rate. Well, the rate, if we solve for rate, is distance divided by time. And we have all the information here to solve our two equations. So for the slower truck, it's going to be 301 divided by 7. That will equal 43. And for the faster truck, which went 357 miles, for also 7 hours, that would be 51 miles per hour. And that seems reasonable. Find the speed of the two trucks. And again, you'll be putting this, if you get one like it, into an equation that they're asking about the slower truck, the faster truck. Now, I will be giving you a worksheet dealing with many more problems that are word problems, putting them from English into algebra. That's going to be part of our lesson, and giving you the practice of doing it. Now, we're not going to solve them. We're just going to work on converting English to algebra. That's in a separate lesson. Now, let's move it up, and we're going to take a look at example 2. Now, in example 2, it requires some background. So let's do some background here. Now we have two functions One is a cost function, which we'll call C of X, and one will be a revenue function, which we will call R of X. Now, what does this involve? Well, when I was in a junior achievement company back when I was a little younger than you folks, and in high school, we met with some people from industry, and we were going to make these little copper cigarette holders, which we don't encourage people to smoke anymore, and produce them. Well, we had to have some machinery to, do the cutting and scissors, heavy metal scissors and things. And to make this, we had to have the machinery and the hammers and things too. So we purchased that, and that cost money. These were like fixed cost. Just to get the process going, we had to have this equipment. Now, when we made a particular item, and we'll call the number of items that we make X, it cost, material for that particular item. If we're going to make 100 items, we had to buy the material to make these 100 items. If we were going to make 200, we'd have to buy more material. But these fixed things were fixed. And in real industry, we're talking about the building, the electricity, the pay of the employees, the secretaries in the office, but we're going to keep it simple. So this is what cost function talks about. The necessary money to make an individual project, the materials for that individual item, and then the fixed costs, the bigger investment. If you had to buy machinery, that doesn't affect that's a fixed cost. So together, this is the cost of production. It's like a little mini economics class here. Now, we then determine that, keeping in mind the equipment we needed to make these products and the material itself in making it, and then we wanted to pay off, because we sold shares, we had to pay off our stockholders, that we could sell this for a particular price. And again, for every unit we sold, we would have a particular price. Now, every time we sold something, this was revenue. So that's what we're looking at here. We're looking at a cost function and a revenue function. So here we're saying we had this much in fixed cost, and then let's say $95 to produce a single item. And the sales price of that item is $105. And later we'll do this one, where the fixed costs were $1,400, and then to sell a particular item, let's say, was 30 cents. To make a certain item. We sold it for $1.30. This was our revenue. So that's our background. Now let's look at it in terms of a graph as well. So our revenue, we're going to start at 0, and as we sell items, we end up with a line like so. Now our fixed cost put us up here on cost, and then that graph would look sort of like that. I'm exaggerating a little bit, but what I'm interested in is where these graphs will intersect. Because at this point of intersection, by going above it, this is the area of profit. Okay? And we call this point, this intersection, the break-even point. And here are our equations to work on to see how many units do we have to sell here in order to break even. Well, think of this function as a y. We said we could always substitute a y for this. And in a sense, we have y equals y. So for a over here, we could say 95x plus 1100 equals 105x. So we're equaling each of these y's to each other. Form of substitution. So to solve, we subtract this from both sides, and we get 10x. Divide both sides by 10, and we get x equals 1100. Well, 110, I should say. Now, what does this number mean? Well, this is the number of units we would have to sell in order to reach this break-even point. And that's what we're showing. Now for the next one, it works the same way. 0.3x plus 1400 equals our revenue, which is 1.3x. So again, we subtract 0.3x from both sides, and that just leaves it, in a sense, 1x. They gave us a real easy one here. So for this one, we would have to sell 1,400 units in order to break even. Again, we're showing you the technique. Okay, let's jump into letter C now. Here we have a gift box manufacturing company recently purchased this much worth of new equipment to make gift boxes to sell. So this is like a fixed cost, an equipment cost. The cost of producing a package of gift boxes is this. That is the material that goes in just to make the box. But you needed this equipment to be able to do it. And it is sold for $3. Find the number of packages that must be sold for the company to break even. So here they're asking you to set up your cost function and your revenue function. Well, I happen to have it set up here, so well, fixed cost is going to be $1,000. And to produce an item, it's going to be 50 cents. And when we sell them, we're going to sell them for $3. So again, it's y equals y. So 0.50x plus 1,000 equals 3.00x. So we subtract 0.50 from both sides, and we get 2.50x. Divide both sides by 2.5, and we get x equals 400. Now, we want to stress, what does this 400 mean? Well, this is the number of packages that must be sold for the company to break even. So in a sense, if this were a curve, a graph, I should say, this point here on the x-axis is 400. Okay? Well, that'll wind this up. Again, we're going into this supplemental page where we have, and I'll be using this as a handout, where we will do additional exercises practicing the skill of converting English into algebra and hopefully building up your mastery as we get ready for our test on Chapter 4.